Biologists reintroduced a species of bighorn sheep into a national park and study the growth in the population of bighorn sheep since they reintroduced the species to the national park. The population p of x of bighorn sheep over a period of x years is shown in the table. The function p of x equals 8 times 1 and 384 thousandths to the x represents the sheep population in the national park, where x is the time since the biologists reintroduced the species of bighorn sheep. How long did it take for the sheep population to double? Use number sense to determine the doubled population after their reintroduction into the national park. Write an equation related to the exponential function and use the table to estimate the solution. Okay, so note here the original population. So at 0 years, then the population was 8. And so it should double then at 16 since 8 times 2 is 16. And so then in our equation, the sheep population p of x should equal 16. So 16 equals 8 times 1 and 384 thousandths to the x. And so now to figure out when it'll equal 16, we can actually just look in our table. And so notice here that there's 15 in our table, which is really close to 16, and then the next one goes to 21. And so we know that it's going to be in between those two, and so then we know it's going to be in between 2 and 3 years. And it looks like since 16 is a bit closer to 15 than 21, looks like it's going to be closer to the 2-year mark than the 3-year mark. And so if we had to estimate, we'd say a little bit over 2 years. And another way to do this is just look in the calculator and you can actually find an exact answer. And so now all we need to do is go to our y equals menu, and there we can go ahead and put in our function, and we'll leave out the 16 and just let be y equals, and then we'll use our table to see when that will equal 16. And since we know it's going to be in between whole numbers 2 and 3, notice that our table right now just goes by integers, and so we can only see between 2 and 3. But if we go to table set, which is second window, then we can make our table start. Well, since we know it's going to be greater than 2, let's just make it start at 2. And then you can make it go up by hundredths or as small as you want. Let's just go make it go up by hundredths, and so that we can get a better idea of what the decimal will be. And so if we put the delta table, or how much it changes, as 0.01 or 100ths, then we'll get a more exact answer. So now go to second graph to get our table. And so see, it starts at 2, and then we want to know when will y1 there be 16. And notice it's going up now by hundredths. And so right at 2 and 13 hundredths, it's 15 and 985 thousandths. And so then the sheep population approximately doubled at 2 and 13 hundredths. And then if you want to turn that into months, that'd be 2 years. And then 13 hundredths, well, we could even go just to our main menu here and type in, well, 13 hundredths times the number of months in a year. That's about a little bit over 1.5 months. So even just rounding up there, then the sheep population will double in about 2 years and 2 months. So let's go ahead and summarize our answer. Since the initial sheep population is 8 bighorn sheep, the population would have doubled when there were 16 sheep. The equation 16 equals 8 times 1 and 384 thousandths to the x will yield the solution. The table shows that this occurred somewhere between 2 and 3 years after their reintroduction into the national park. Since 16 is closer to 15 than it is to 21, the population likely doubled closer to 2 years after reintroduction than 3 years after reintroduction. Using table features of graphing technology, changing the step between independent values to hundredths, you could determine that after 2 and 13 hundredths years, the sheep population was approximately 15 and 985 thousandths. Therefore, the bighorn sheep population doubled approximately 2 years, 2 months after they were reintroduced to the national park.